Welcome to 2.2. We're going to look at solving systems by substitution. So we looked last section at solving a system of equations by graphing. Today, we're going to look at another method, which is substitution. So in order to do this, we're going to isolate one of the variables. We're going to substitute the expression into the other equation, solve for that first value, and then we're going to use that value we solved for, plug it back in to solve for the second value. And this really is best for when you have one equation given as x equals or y equals. There's other times you could use it, but when we get down to other methods, the thing to look for is going to be when x or y is isolated by itself. Okay, so let's look at our first example. So we don't have x or y by itself, but we can take this equation and easily isolate x. So if I have x plus 6y equals 2, I can bring that 6y over, and I just get x equals negative 6y plus 2. So now x is by itself, so I'm going to take this expression and plug it into x over here. So that gives me 5 times negative 6y plus 2 plus 4y equals 36. And now I just have one variable in this equation, which is y, so I can solve for that. So I get negative 30, I'm going to distribute this, plus 10 plus 4y equals 36. Negative 30y plus 4y, those are like terms. So I get negative 26y plus 10 equals 36. Subtract 10. So I get negative 26y equals 26. Divide by negative 26. So y equals negative 1. Okay, now I'm going to take this value and plug it back in up here. Oh, sorry. I'm going to plug it back in here and solve for x. So I get x equals negative 6 times negative 1 plus 2. So that's 6 plus 2, so x equals 8. And I'm going to write my solution as an ordered pair, just like before. So my solution is 8, comma, negative 1. Okay, in example 2, we do have our y isolated, so we already have y equals 4x plus 2. So I'm going to take that expression and plug it in for y up there into that top one. So I get 3x minus, I'm going to put parentheses around that 4x plus 2 to remind myself that there's really a negative 1 there that I need to make sure I distribute to these values. So I get 3x minus 4x minus 2 equals 5. Here I have like terms. So 3x minus 4x is negative 1x minus 2. Add the 2 to both sides. So negative x equals 7. Divide by negative 1. So x equals negative 7. Okay, now I'm going to take that value and plug it in back up to here in my equation. So y equals 4 times negative 7 plus 2. So that's negative 28 plus 2. Whoops. So that's negative 26. So again, my final answer as an ordered pair is negative 7, comma, negative 26. And that is solving systems by substitution.